Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook, this one question lost more marks than almost any other on last year's papers, and it only needs one simple idea to fix. Imagine you finish a circle question, give an answer, and then the examiner crosses it out because you wrote an unjustified assumption. Heart-sinking, right? Stick with me for the next 12 minutes and you'll know the exact reason statements that win method marks every time.
Promise and roadmap. Here's what we'll do. I'll teach you the single rule you must know about cyclical quadrilaterals, show you why it works with a quick diagram you can sketch, point out the common exam mistake that costs marks, walk through a 3 to 4 mark worked example showing which steps earn method marks, and give you one quick win to use in timed practice. Ready? Grab a pen. You'll want to sketch along for 1 minute.
The concept. First, the rule. In a cyclic quadrilateral, that's a four-sided shape inside a circle where every corner touches the circle, the opposite angles always add to 180 degrees. Say you have angles at A and C. Angle A plus angle C equals 180 degrees. Same for B and D. No memorized trick, it's a direct consequence of the circle's arc properties.
If you're listening without the diagram, sketch a circle, mark 4 points around it clockwise, and label them A, B, C, and D. Join them to make the quadrilateral. Now, imagine the arc from A to B, and the arc from C to D. The angle at A subtends the opposite arc, and the angle at C subtends that same arc from the other side. Two angles subtending the same arc are supplementary. They add to a straight line, 180 degrees. That's the why, not just the rule.
Let's make that concrete with numbers. Suppose angle A is 70 degrees. Without doing any new construction, you can immediately say angle C is 110 degrees, because 70 plus 110 equals 180. That's angle chasing. You use one known angle to get another. Sound simple? It is, but the examiners expect you to write the reason, not just the numbers.
Angle chasing technique, step by step. 1. Label every angle you know on the diagram. 2. Identify pairs of opposite angles in the cyclic quadrilateral. 3. Apply opposite angles in a cyclic quadrilateral sum to 180 degrees to link them. And 4. Substitute and solve. At each step, write the short reason line so the examiner can award the method mark even if your arithmetic slips.
Quick pause to practice. Sketch the figure. Write angle A equals 50 degrees at the top left. Then write A plus C equals 180 degrees beneath it, and calculate C equals 130 degrees. Say that out loud as you write it. It helps memory. The exam technique, now the marks. A typical 3-4 mark cyclic question breaks down like this. M1 for a correct equation relating angles, for example, A plus C equals 180 degrees, or angle in the same segment equals M1 for correct substitution or rearrangement, and A1 for the final correct value. If it's 4 marks, you'll often see an additional M for setting up a second relation. The key is this: examiners award marks for the method, not just the final answer, so write the equation clearly.
What do examiners want to see in your script? Short, precise reasons. Good examples. Opposite angles in a cyclic quadrilateral sum to 180 degrees, or angles subtend the same arc so they are equal, depending on the link you're using. Avoid vague lines like by circle rules. That's not enough. Write the specific rule you used.
Example of a lost mark. You write numbers and conclude C equals 120 degrees, but you never wrote A plus C equals 180 degrees, or any justification. The examiner cannot give the M mark because the method is missing. Even if your arithmetic is wrong, show the method and you can still collect M marks. That is where marks are for the taking. Let that sink in.
The quick win, a 3-step habit you can use in every timed paper. Step 1, immediately annotate the diagram. Mark the given angles and label the quadrilateral points. Step 2. Write the reason line the instant you use a theorem. For example, A plus C equals 180 degrees, opposite angles in a cyclic quadrilateral. Step 3. Perform a 10-second impossibility check. If any angle you found is negative or exceeds 180 degrees, pause. You made an error. This habit takes 60 seconds but saves marks.
Do it now. Next time you practice, set a 1-minute rule. Before you calculate, write the reason line. Watch how many extra method marks you pick up. This is a grade 9 move because it keeps your script exam-friendly and makes partial credit almost automatic. Worked example. Here's a short question you might see. In cyclic quadrilateral ABCD, angle A equals 64 degrees and angle B equals 92 degrees. Find angle C. Step 1. Identify that A and C are opposite, so write A plus C equals 180 degrees. That's M1. Step 2. Substitute 64 plus C equals 180. Rearrange to get C equals 116. That's M2 and A1 for the answer. If the question also asked for angle D, you'd use B plus D equals 180 degrees and do the same. Write each line on a new line so the examiner can follow your method.
If you run out of time and only wrote 64 plus C equals 180 without solving, you'd likely still get M1 for the correct setup. So even a partially worked line is valuable. Write it down. Don't just think it.
Common mistakes in a short practice plan. The biggest single error is making unjustified assumptions from a messy diagram, for example, assuming 2 lines are parallel or equal without a reason. Fix it with 5 short sessions, 5 days, 10 minutes each. Day 1, practice labeling diagrams. Day 2, write reason lines only. Day 3, do 3 timed 3-mark questions. Day 4, check impossible angles and edge cases. Day 5, take a mixed set and note method mark gains. Small, deliberate practice beats last-minute cramming.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find an annotated worksheet and more worked solutions at jcacademyonline.co.uk. The link's in the show notes. Until next time, trust the process and nail that exam. Stay curious.